Yes, good evening. My name is Jojo Kwaro, and I want to look at something. Uh, let's look at introduction to SCADA. So SCADA stands for Supervisory Control and Data Acquisition. A SCADA system is a software system used for controlling and monitoring, and analyzing an industrial process. So SCADA is a key software element in critical infrastructure control. So simply, SCADA is a software which is used to control hardware, which could be anything, say servers or drives. So it's an application where data is collected from a system to control that system. It collects the data from the system to control it. So it acquires the data in order to control the system. So it acquires and controls at the same time. Yeah, it is the one wide area network control system for dispersed control assets that need to work together. For example, the oil pipe and gas pipelines. Let's look at the history of SCADA systems. So it grew out of telemetry systems developed for the space programs. By that time, everything was analog, So through the development of microprocessors and integrated circuits, microprocessor-based digital telemetry systems were developed. Yeah. At the same time, the radio telemetry was being used for supervisory control and data acquisition, which gave birth to the modern SCADA systems. So the integrated circuits could multiplex data and provide all the information. So there is when modern SCADA came up. So let's look at SCADA architecture. So SCADA is a control system with architecture that uses computers, network data communication, and graphical user interfaces for high-level process supervisory management. Yeah, but it also uses other peripheral devices like programmable logic, controllers, and discrete PID controllers to interface to the process plant or the machinery. Get? Yeah. So the basic architecture of SCADA is control center, which is a computer system connected with the Ethernet port, and to the Ethernet port, the PLC is also connected to the Ethernet port. So the PLC is connected to various field instruments, So the computer has SCADA software which can interact with the field instruments that are connected to the PLC, So the two important elements involved in the modern SCADA systems are the RTU and the central station computer. So SCADA systems have mainly four functions. The first function being data acquisition, data communication, data presentation, and control of sensors, whether analog or digital, and also controls delays that directly interface with the managed system. Yeah. So there are small computerized units deployed in the field at specific sites and location, and they act as communication networks that connect the SCADA master unit to the RTUs, in the field remotely, in the field remote telemetry units, So these RTUs serve as local collection points for gathering reports from sensors and delivering commands to control delays. I mean, not delays, relays, relays. So SCADA has almost become synonymous with the HMI through the advent of Windows and the high-resolution graphics, Now, a very important part of the most SCADA implementation is the alarm handling. So the system monitors whether certain alarm conditions are satisfied to determine when an alarm event has occurred. Once an alarm event has occurred or has been detected, one or more actions are taken. For example, the activation of one or more alarm indicators and perhaps the generation of email or text messages. So the management or the remote SCADA operators are informed, and at most cases, a SCADA operator may have knowledge of the alarm event. So SCADA systems are very important nowadays. Yeah. So let's look at the uses of SCADA systems. SCADA systems are used to control and monitor physical processes. Yeah. For example, they are used in the transmission of electricity, transportation of gas and oil in pipelines, water distribution and traffic lights. The operation of the traffic lights. Yeah. And there are plants which also use the SCADA, like for example the power plant uses the SCADA system to detect current flow and line voltage and monitor circuit breakers, circuit breakers within the circuit. Another example is also in the chemical industry, where SCADA systems can be used to control the level of the tank, the flow of chemicals, temperature, and many more activities. Yes, so let's also look at the IIoT. It stands for the Industrial Internet of Things. It is referred to as an industrial framework whereby a large number of devices or machines are connected and synchronized. Sorry, are connected and synchronized through the use of software tools and third platform technologies in a machine to machine and Internet of Things context, or later the Industry 4.0, or the industrial Internet context. So it all begins with the collection of data, and you have to change the data into information in order for the machine to understand. Like you also have to connect the data, like let's say time shaping. For example, this data was created this time using this machine and blah blah blah. So you know what I'm saying. After this now, you are able to go to the data optics world and the Kaizen world using the artificial intelligence. Get. So already there is a lot of data in your industries. For example, in the sensors and the robots. So you first have to connect the data. You first have to link the data for the understanding of the system. For the data to be linked, you have to connect the data and activate synchronization. So the data flows in the network, and so collection of excess data leads to an overflow. Due to slow processing and hence leading to loss of data, which is not good in an industry. So it is important to gather precisely the frequent data frequently when looking at the manufacturing process to avoid loss of data. Okay. So and because of this, let's look at edge computing. Yeah. So edge computing does the filtering and changing data into the information. Like for example, at the edge, before it's in edge computing, the computers are not directly connected to the cloud. So at the first point, there's a computer which does the filtering and changing data into the information for machine to understand. So it is the initial process of data, and it throws away data that is not needed. The unneeded data is thrown away. So it instantly connects the data relevant to the other data and sends it with extra information, so it's easier to process in the cloud. So as I've said before, in edge computing, the system is you're not directly connected to the cloud. There's a fast computer with the filtering, and so the good aspect of edge computing is time reaction. It is fast. If something happens or something is wrong in the industry, it alerts very fast, and the machines are shut down. So it is very fast. Another good aspect of edge computing is the system reserves and security. So it is very secure. As I've said before, you're not connected with edge computing. You're not connected directly to the cloud. So the information you have in your computer is not directly connected to the cloud. You must go through different stages of computers, like the first computer filtering, then now the information is sent to the cloud. So system reserves and security, not connected to the cloud, so it is safe. The information in the cloud is safe, and not just it is not accessed by anybody anyhowly. So cloud computing is a place where you develop knowledge, and edge computing is where you put that knowledge in action. Thank you for listening.